Hi everybody, so welcome to chapter 3. In this chapter we're going to start with a little bit of a review of something called average rate of change and secant lines. Now you should be familiar with some of these things from previous classes, but we thought it was worth taking some time to talk about them and review a little bit before we start using them in this chapter. So let's start by reviewing average rate of change. The average rate of change is another way of describing the slope between 2 points. When we're finding slope, we often say that it is the change in y divided by the change in x. Sometimes we say it is the rise over the run between 2 points. Sometimes we use the slope formula y2 minus y1 over x2 minus x1. And sometimes, and this is the way we're going to use it the most in calculus, is instead of saying y2 and y1, we say f of b minus f of a over, and instead of saying x2 and x1, a lot of times we will just say a and b. Now this is because oftentimes we are asked to find the average rate of change over a specific interval of x values. So usually we're going to be given this interval of x values and asked to find the average rate of change, which is why we usually write our slope formula with this kind of a notation. All right, let's take a look at secant lines now. So a secant line is something that you may have heard about in geometry. It's a line that connects 2 points on a curve. The slope of the secant line is also known as the average rate of change. So when we find regular old slope, we are actually finding the slope of the secant line. When writing the equation of a secant line, we usually use point slope form, which, for those of us who may need a little refresher, looks like this. Y minus y1 equals m parentheses x minus x1, where the y1 and the x1 are a coordinate of an ordered pair that the line passes through, and m is the slope. So let's take a look at an example problem. Let f of x equal x squared. Find the average rate of change of f of x over the interval from -1 to 2. Then graph the function and draw the secant line. Finally, write the equation of the secant line over that interval. So as I said before, we are usually given some sort of an interval over which we are finding the average rate of change. In this case, a would be -1 and b would be 2. So to find the average rate of change, I would need to find f of b minus f of a all over b minus a. Now, in order to find f of b, I'm going to take my value for my b, which is 2, and substitute it into my original equation. So I would be finding f of 2 minus f of -1 over 2 minus -1. If I substitute 2 into my original equation, I'm going to get 4 minus, and if I substitute 1, I get 1 over 3, which means I get 3 over 3, which is 1. So the slope of my secant line would be 1. Now, if I were to make a graph of this situation, the graph of x squared starts at 0, 0, and we kind of increase with this pattern where we go over 1 up 1, over 1 up 3, over 1 up 5. So the graph of my x squared graph would look like this. Now the slope of the secant line connects 2 points. So I'm connecting the point where x is -1, which is here, with the point where x is 2, which is here. So my secant line would look like this. as you can see, the secant line is just connecting 2 points on this curve. And if I look at the rise over the run on this graph, I would be going up 1 over 1, up 1 over 1, up 1 over 1 for this blue line, which matches the slope that I found here. Now, the equation of the secant line, we need two things. We need a point to write the equation in point-slope form, and we need a slope. The point and the slope are relatively easy to find. The slope is just 1, which we already calculated, and the point could be either one of the ordered pairs from the endpoints. So if I use -1 as my x value, then I would get the y value by substituting it into the original function, which would give me 1. So for my equation, I would write y minus whatever my y value was, which was 1, equals m, which is 1, parentheses x minus whatever my x value was from my ordered pair. Since I'm going to have a minus and a minus, it's going to turn into a +1. And that would be my secant line. The nice thing about what we're doing is we don't ever need to rearrange that and put it into slope-intercept form. That's good enough. Now, an application of this idea is this idea. Suppose that you travel 200 miles in 4 hours. What is your average speed? This is another way of saying average rate of change, because speed is a rate of change. So to figure this out, we would do the change in distance over the change in time. In other words, the change in y over the change in x. We know we went 200 miles in 4 hours, so my average speed would be 50 miles per hour. Now this means that on average you went 50 miles per hour, but what it does not mean is that you traveled 50 miles per hour the whole time. It's possible that you could have gone faster than that and slower than that on certain points of your journey. It's just that that was how it averaged out. Coming up in this chapter, we're going to be talking about how to be more specific about what was happening at those moments in your journey where maybe you weren't going 50 miles per hour, and how do you find those values. Thank you guys so much for watching. I hope you have a great afternoon, and I will see you next time.